Hi everyone, so this video is going to be about graphing lines from equations. So you're given the equation of a line, you need to put it onto a set of axes, figure out what it looks like, and graph it. So we're going to look at two different methods. There are many more than two methods, but two is what we're going to look at in this video. We're going to start by looking at doing it by using a table of values, and then we're going to look at using the gradient and the y-intercept. So we'll start with, we'll call this method 1, table of values. So we talked about tables of values in previous sections, and so this shouldn't be new in that respect. So we've got the equation y equals x minus 2, and we're asked to construct a table of values using the following numbers as our x values. So we can go ahead and fill in our x values, -3, -2, -1, 0, 1, 2, and 3. So almost always, when you're constructing a table of values, you're going to want a variety of x values. You're going to want a couple of negative, a couple of positive, and a 0. Oftentimes the question will tell you which specific values to use. If it doesn't, just follow that sort of line of thinking, a few negatives, a few positives, and a 0. Okay, so then how do we actually do this? Well, we start with the equation that we're given, y equals x minus 2, and then we one at a time plug in the values for x and figure out what the corresponding value for y is. So y equals, if we take -3, our first value from the table of values, subtract 2, we've got y equals -5. So we'll plug in -5. On to the next one, y equals x minus 2, y equals -2 minus 2, y equals -4. Okay, y equals x minus 2, y equals -1 minus 2, y equals -3. On to the next, y equals x minus 2, y equals 0, minus 2, y equals -2. Y equals x minus 2. This gets a little monotonous, I'm not going to lie. For the more complicated ones, it's certainly more important to show all of your work. For a simple one like this, like I know I'm just taking away 2 from each of these, so I know that if I take away 2 from 2, I'm going to get 0, and I know if I take away 2 from 3, I'm going to get 1. So in something like this, you probably wouldn't need to show out all of the steps of your work. Again, it's always like a risk-reward thing, right? If you don't show your work and you make an error, then there's nowhere for me to go to look for partial credit. Okay, so now we've got this set of points that make up our line. So we go to our graph paper, and I'm just going to quickly translate over the points that we had. So whoops, that's not -1. So these are the points that we had from what we just worked out from our table of values. 3, 1. Make sure I got those all right. 2, 1. Yeah. Okay, so then we draw ourselves a set of axes. Now you want to have a quick look at what your largest value is and make sure that your axes will take you that far. So the biggest number we have is -5 as a y. 1, 2, 3, 4. And I have enough room to do a -5 as a y. So you take each of these points and you plot them onto your set of axes. So we've got -3, 1, 2, 3, 4, -5. So first point there. And then we've got -2, -4. And we've got -1, -3. And we've got 0, -2. We've got +1, -1, 2, 0, and 3, 1. Now, this whole unit is about linear equations, so if you've done this properly, you should end up with points that are in a line. Now, you could obviously make the exact same mistake every single time and end up still with points in the same line but be wrong, but if you have 6 points in a line and one that's off, probably that one is off. Now, because x could be any value, it means it could actually be decimals. So we're going to connect these lines, or these points rather, because it could in fact be that x was 1.5. And so there is meaning between the points. Okay, and then that's it. That's how you do it for a table of values. So take your x values, plug them into your equation, figure out your y values, get those coordinates, plot them on a set of axes, connect the dots, extend past the last dots, arrows on both ends to show that that line goes on forever. So that's how you take an equation and use a table of values to figure out what it looks like when it's graphed. So the other way that we're going to look at this today, we'll call this method 2, is to use gradient and y-intercept. This method may at first seem more challenging, but it is by far faster when you kind of master it a little bit. Okay, so when you have an equation written in what is known as slope-intercept form, y equals mx plus c, that is the equation for a straight line, and the gradient is represented by m, which is the coefficient of x, and the y-intercept is represented by c. So the coefficient of x is your slope, or your gradient, and the number that's on its own is your y-intercept. Only when it is written in this manner, with y completely by itself on the other side, and then mx plus c on the other side. So when you know those two things, you automatically know two things about what this graph is going to look like. You know where it crosses the y-axis because you know what the y-intercept is, and you know the slope. So we're going to show how to use those two things to graph the line. So we're going to start with a little bit of practice on identifying slope and y-intercept, or the gradient and the y-intercept. So we're asked in this to find the gradient and the y-intercept. So gradient, remember, is represented by an m, and it is the coefficient of x. So in this case, the gradient is 3. And the y-intercept, which is represented by c, is the number that is by itself, including the symbol, so -2. So on the second one, m, which is slope, is the coefficient of x. So even when it's written in a different order, it is still the coefficient of x, which is -2. And c, the y-intercept, is the number on its own, which is 7. And then the last one's a little different. So the last one, we don't have an x value at all. So there is no coefficient on x. So if there's no coefficient there, it is actually 0, if there's no x at all. Now, if you had just a single solitary x, then the coefficient of that would be 1. But if there's no x at all, the coefficient is 0. There are 0 x's. And then the number that's on its own is also 0. So that's a little bit of a special case one there. Okay, so identifying the gradient and the y-intercept is the first step in order to use those two pieces of information to graph your line. You've got to get those bits of information first, then take them to your graph paper and graph them. So that's what we're going to look at in this next example. So just to summarize, in order to draw the graph, y equals mx plus c, you're going to first figure out what the y-intercept is, and then you're going to plot that point. Because remember, the y-intercept is a point. It's a point that exists on this line. So knowing the y-intercept gives us one of the points in this infinite set of points. We just need to know what direction to go from there. And that's where the gradient comes in. So you plot the y-intercept and then use the gradient to count your way to another point. Then once you have those 2 points, join the points, extend the line off in either direction, arrows on the end to show that it's a line, and that's it. So if you wanted to break it down in steps, find slope or gradient and y-intercept. So those you just get from the graph, like we did in the previous example down here, or get them from the equation rather. You just pull them right off of the equation. So once you have that, then you plot the y-intercept. remembering that that is a point. And then you use the slope to count to your, no, count to the next point. And then join the points, extending in either direction with arrows on the end. Okay, so let's take a look at that in practice. So we've got two here that we're going to do. We're going to do one on this page and then we'll go to the next one. So if we're looking at part A, we have y equals 2/3 x plus 1. Step 1, identify slope and y-intercept. So gradient or slope is the coefficient of x, remembering y equals mx plus c. M slope, c y-intercept. So the gradient of this is 2/3. So the coefficient of x. The y-intercept is the number on its own, 1. Okay, so step 1, get those two pieces of information. Step 2, plot the y-intercept. So we'll draw ourselves a set of axes here. Step 1, find those two things. Step 2, plot the y-intercept. So the y-intercept is 1. So that means that graph, that line, will cross the y-axis at point 1. So that's the first point we know on the graph. Then, remembering back to when we talked about slope, slope is the vertical step over the horizontal step. So 2 is my vertical step, 3 is my horizontal step. So from the point that I know is on my graph, my y-intercept, I am going to count 2 vertical, 3 horizontal, and that is where the next point on my graph is. So I have used the slope to count my way to the next point. So once I have my 2 points plotted, then I go ahead and connect my dots with a ruler, extending my line beyond both of those points, arrows on the end to show that it's a line that goes on forever in both directions. Okay, let's look at the second one. So the second one, we have y equals -2x minus 3. So first thing, identify the slope, the coefficient of x, -2. The y-intercept is the number on its own, -3. Okay, so away we go. We'll draw our set of axes with a ruler. And then we're going to plot the y-intercept. So that's the first thing we plot. So y-intercept of -3. So this line is crossing the y-intercept at -3. Then we use our slope to count our way to the next point. So this doesn't have, or this is not written as a fraction. So to make my job easier, I'm going to make this a fraction, knowing that the top is going to be my vertical step and the bottom is going to be my horizontal step. So from the point that I have constructed on my graph, I am now going to go -2 vertically. So that means I'm going down 2 vertically and horizontally 1. So then I'm going to make my next point at where that landed me, down 2 and over 1. And then I'm going to get a ruler and connect those points, extend beyond them, arrows on both ends to show that it's a line and goes on forever. Which makes sense that this line should go down as I read it left to right because it has a negative slope. So that makes sense that my line is going down. Yeah, so that's how you use the second method to graph lines. So let's recap. We are learning 2 ways to graph lines from equations. One, using a table of values. So you take some values for x given or made up by you. You determine the corresponding y values, giving you sets of coordinates, which represent points. Plot those points on your graph, connect the dots, extend the line in both directions, arrows and all of that. Second method is to use the gradient and the y-intercept. So taking those two bits of information directly from the equation, the coefficient of x being the slope or the gradient, and the y-intercept being the number on its own. Taking those two bits of information, plotting the y-intercept where it needs to be, and then using your gradient to count to the next point on the line. And then connecting the dots, extending your lines out in both directions, arrows on the end, and ta-da, you've got yourself a graph. Okay, thanks so much.